Hello everyone, and welcome to the tutor training video for the first tutorial of the Big Data NLP project, which is a sentiment analysis project of COVID-19 related data, which is collected from Twitter. Just again that this video is meant as a tutor training guideline for the purpose of the Big Data hackathons. Okay, so let's get started. In this tutorial 1 of 3, participants will learn how to use the Python Tweepy library in order to collect COVID-19 related Twitter data, or any Twitter data for that matter, from the Twitter API. So the tutorial concerns the collection of this Twitter data, as well as a bit of cleaning and pre-processing of this data. So there are many ways to collect or stream data from Twitter, but in this tutorial we demonstrate the collection of data using Tweepy rather than streaming for various reasons. All right, so these are the libraries that are needed for the tutorial. Normal sort of pandas and NumPy, etc., matplotlib. We've got the Tweepy library here, and we'll see how that's used. We have word cloud for a bit of fun later on, looking at making a word cloud using our tweets to see the most common words that occur in the tweets, and then a few other libraries that we need in order to do the pre-processing and cleaning, such as stop word removal, etc. Okay, so that's the first thing that's done. This is normal. And then going on to now collecting the data. Hopefully all tutors as well as participants, by the time they've got to this stage, would have obtained their Twitter credentials. That's the API key secret, and then the access token and the access token secret. The bearer token is not needed for the purpose of this tutorial. So let's have a quick look at this Twitter credentials.py file. All right, so here, I'll just show it very quickly. That's got my credentials. So the participants will have to copy and paste. It will be given to them empty, of course. I mean, the other text, but not the keys and the tokens. And they will just copy their tokens and keys and paste them into this file and save the file. So if we then import the credentials from this file as TC, and we then use these credentials, these 4 credentials here, to obtain authorization and create this auth object. And now we'll create sort of the API object, while passing through our authentication information. But we've also said that we're going to enable the waiting when rate limited. So if for some reason Twitter feels like we're collecting or asking for too many tweets and we're rate limited, so basically this will allow for you to pause rather than stop collecting tweets, and after rate limit time has passed, the code will continue to collect tweets. And I'll describe shortly when that might happen. Okay. All right. Now just creating a very simple search query around COVID-19, which we do in cell number 5. You know, we also show participants, you know, if they go to the link here, a bit more about how to refine your search, which they will need to do for when they tackle the hackathon task. They will have to figure out how to use the various filtering and search rules in order to refine their search query. For example, they may want so they might want certain tweets to have certain words or other words, or they, like in this case where you said or they may require each tweet to have say both the words vaccine and coronavirus, or vaccine and COVID, or pandemic and vaccine. For example, if their topic of choice is about vaccines. So when actually working on hackathon task, they will need to look a bit more into this, how to really get the most information or the most relevant kind of tweets that they're looking for in relation to their specific research question that they're asking for the hackathon task. So yeah, I should just mention at this point that the hackathon task will ask them to collect their own Twitter data around COVID-19, but a specific topic around COVID-19, and collect tweets around this so that they can analyze or draw some results or some insight on the sentiment around various aspects of COVID. So the kind of project questions they could, or research questions they could come up with could be, you know, how do people feel toward the vaccine, or how do people feel about their government's response, or how does feelings towards the virus or validity of the virus differ from one country to another, because we will show later in this tutorial how to get tweets from specified regions around the world. So they could collect tweets from 2 specific or 3 specific regions and compare the sentiment around vaccines or a specific topic. So it is up to them what research question they come up with, which is part of the fun and part of the hackathon challenge. Okay, so getting back to the search query, like I said here, we've created a very simple one, and for the purpose of their task, they'll have to make it a bit more sophisticated. And we've also chosen to filter out things like retweets and replies, so that this doesn't sway or impact or modify the sentiment too much of the data that's collected. Okay, so let's run that again. And now we're ready to start searching or connecting with the API for obtaining tweets. All right, we've chosen English, but as I've stated, Twitter supports 34 different languages. Although for the purpose of this hackathon, it's essential that everyone work with English, because the training data that we've compiled for the purpose of tutorial 3 is all in English. So, and it would it would not be possible for participants to create their own training data, as we have spent many hours actually making labeled data sets. So we've collected tweets around COVID-19 from various parts of the world, and we've labeled each tweet as either having a positive, neutral, or negative sentiment. So, and we have a few thousand. So it's not feasible for participants to create their own training data for the purpose of this hackathon. Of course, after the hackathon, they could experiment with such things, but for the purpose of the task and the hackathon, they have to use the training data that we provide, and therefore have to work with English tweets, as all training data is in English. Okay, we also, so we have my search, which we've specified here using the search words and our filters. The language is English. The tweet mode is extended, and that just allows for us to obtain the full text, which is not truncated in any way. And we've also said that we will collect, for now, 100 tweets. Okay, so it takes a few seconds, and then we want to have a look immediately at what we have to see if the search query is, working as it should be, or that we're getting the kind of tweets that we would expect from our search query that we've put together. So printing out the first 20 tweets, and we can see that they're all about the pandemic or lockdown or COVID-19. So all working well. Okay, and we've here chosen to print out the full text attribute of the tweet object. But in actual fact, the tweet object has a whole lot of other data associated with it. So each tweet has, in addition to the full text attribute, has a whole list of many different attributes. So we just go ahead and print out all the attributes for the first tweet, just to give participants a feel, an idea for just a huge amount of metadata that's associated with each and every tweet. So that the date, time, the ID, the user information, the information of those who have retweeted or followed this user, just a whole lot of metadata that for some people can be very useful for a number of different reasons. But yes, it's just to demonstrate to participants just how much metadata is associated. That we have information about the followers, friends, etc. So showing just how much information you can get about each single tweet. Okay, so and this output is in JSON. Okay, so we then explain here that we've used the API search method that we used above limits actually the count, where we said count equals 100. That is actually the upper limit when using the simple API.search method. But an easy way around that in order to get more tweets is to use sort of a pagination tool, which is Tweepy's cursor object that they offer, and it basically allows you to page through stored up tweets. Although I think it's very good to note from now that with the free version, the standard version of the developer account, you can only access tweets from the past 7 days. If you want more historical data, then you'd have to have a paid account. So yes, we are limited by this, but for the purpose of this demonstration and this hackathon, it is sufficient. You can always apply for a advanced account, and there are some free options where they do allow tweets to be collected from the past 30 days, but they are limited in terms of the number of tweets that you can collect. So it depends on each individual's objectives. So what we're going to do now in order to collect more than 100 tweets is use this cursor object of Tweepies, and we're going to only collect 1,000 tweets at a time as a maximum. And the reason for this is that if you try to collect more than 1,000 tweets per minute from the API, you will most likely be rate limited, and that's not a problem. It's usually 5 minutes or a few minutes just to control the amount of data that you're collecting. But in order to not run into these delays, it's best to just collect 1,000 at a time. So you can do as many queries as you want, but keep it to 1,000 at a time. So usually if you're going to specify various regions where maybe there's not a lot of tweets coming through, then you may not even exceed this 1,000. But if you're just pulling from a place like the UK or the US, then you very well may have many thousands of tweets that you'd like to collect. So as we've said here, if when trying to collect this large number of tweets using this cursor object, if you run into an error, you can just simply go here and look at the error code and investigate what the reason is, whether you're being rate limited or whether there's some sort of other issue with the kind of query, or not the query, sorry, but the request that you've put through. All right, so we've done that, and now we will extract the full text from each tweet, as well as the time and date information and the user location. In this case, the user location, when just using tweet.user.location, is the location that the user actually inputs when creating their account. So it's not always accurate. It could be left blank, or they could write absolutely anything. So some people write funny things like planet Mars or something like that. So it's sort of useful, but also not accurate, and we will show how to get around that later in the tutorial. Okay, so collecting 1,000 tweets, like we say here, should take around 2 minutes, and that's why we've got this magic command at the top, which after the cell is run will show us how long that cell took to run. So I'm just going to go ahead and run it. Actually, let me not. Okay, now let's run it, and I will pause for those 2 minutes and come back once it's done. Okay, so it's now finished running, And we see that it did take around 2 minutes to collect 1,000 tweets. And it's all stored here in this object tweet info. The data that we requested, like I said, was the tweet's ID, the full text of the tweet, so the time when it was created, and the user location. So then the next step is to put all this into a nice, neat pandas data frame in order to have everything well organized and be able to easily work with the data. Okay, so like I said, in terms of the location, you will see sort of that not every tweet has a location, and the ones that do, it's dependent on what the users actually inputted. So, for example, this is a very confusing location, but you can see that because we haven't specified a region from which we'd like to collect tweets, they're most likely to be from anywhere in the world. Okay, so then what we do is just have a look. Again, it's always good to just have a look and see that things are as you'd expect. So we have a look at the first 20 tweets by just printing the head saying .head. Very easy to work with in pandas. The text data frame, the text column of the data frame. And again, we see that it is, as we expect, tweets around COVID-19. So seems to be working well. Okay, we've now, that completes section 1 of tutorial 1, which has to do with collecting the tweets. And we now move on to section 2, which is the cleaning of data and pre-processing of the data. So cleaning involves sort of removing various, URLs, hyperlinks, etc., and numbers, things that are not going to serve us for our NLP analysis. And then pre-processing is a few other techniques that need to be done in order to ensure that the data is very well prepared for the kind of NLP, specific NLP task that we're going to perform. Okay, so first we do some cleaning using the regular expressions module. So this will just search for an expression and replace it with whatever you say, in this case, substituting with a blank space. All right, so we've chosen to remove hyperlinks, at mentions, as well as any of these numbers or characters. Or anything that isn't, sorry, anything that isn't one of these numbers or characters that are listed. So we've kept things like the hashtag, since it's very relevant in understanding tweets, question marks and exclamation marks, because this is also very relevant when looking at sentiment. Okay. So we run that, and then we apply this function, this clean text function, apply it to the tweet text, and then have a look again at those same 20 tweets. And we see, as compared to before, that now all hyperlinks, emojis, etc. have been removed, but we still have numbers, we still have our hashtags. So we still have question marks, we still have things that will provide useful information when doing a performing sentiment analysis. Okay, so moving on then, we've now cleaned it, the text, but we now want to do some pre-processing for NLP purposes. The first step that is usually always carried out when doing any sort of NLP analysis is converting all the text to lowercase. And this is done so that it's not always done actually, but depends what method of sentiment analysis you're using, which we'll discuss a bit more in tutorial 2 and 3. But in some cases, you will want to convert all the text to lowercase so that words that are the same words, but maybe in appearing in uppercase and lowercase will not be seen as two separate words in your corpus. So let's go ahead and just convert all of them to lowercase, which has worked. All right, the next step of pre-processing is to remove what we call stop words. These are words that are commonly used that don't add any value to the NLP objective. So in this case, to the sentiment. And if you have a huge database, you don't really want these words taking up space in your database, in your corpus. So we go ahead and remove them. And we're just using the Natural Language Toolkit's list of stop words, which was downloaded at the beginning of the tutorial, and for the purpose of letting participants have a quick look at what this looks like, what kind of words are in the stop words list. You can do so by just scrolling through so that they understand what kind of words are considered stop words. And then it's very important to note that the stop words list can always be amended, and we can append our own list of stop words onto this. So that's what we've done here. Because we know we've required our tweets to all have the following words, we can then make sure that the words that we had in our search query are removed from each tweet, because this will also sway certain types of sentiment analysis tools, just because we know already that it's going to occur in each tweet, which won't help us to sort of with certain kinds of NLP analysis, again, will not serve us in trying to determine sentiment. All right, so now that we've created this list of stop words, we then define a function to remove all of these stop words from the text, and then apply this remove stop words function to the tweet text, and again print out the first 20 tweets. Now the tweets will look quite strange. Will read quite oddly once stop words have been removed, and it's explained in this text that why would we want to do this if it means that our tweets no longer make sense when we read them. But there are some cases when using certain methods of NLP, will be shown in tutorial 2, where you would want to do this. So for now, let's just accept that this is sometimes necessary, and we see that it works, even though it reads a bit strangely. And now that we've got only the relevant words showing or in our text, let's have a little fun with a word cloud. So a word cloud will go through all the text and will display words that show up most frequently in all our tweets. So when we do that, we see here that these are the kind of words that are coming up most often in our tweets around COVID-19. It's a very interesting mix. And they may not be individual words, but they can also be pairs. I think there are settings for this, and participants can feel free to play around with a few of the settings for the word cloud to see what they can generate. But yes, obviously the bigger the word, the more frequent its occurrence. Okay, and that's the end of section 2, which has to do with cleaning and pre-processing of the data. And we then come to section 3, which is about refining the search query, specifically in terms of the location of the tweets. Okay, so when using this geocode parameter in the search query, you can actually specify a latitude and longitude, as well as a search radius in either kilometers or miles, but you'll have to specify the search radius and the units, as we'll show below. But again, just a reminder here that with the free version of that we have of the developer account, that we can only access tweets from the last 7 days. So if you put in dates that are prior to the last 7 days, you will not obtain any tweets, or it may just I think it might just give you a default of the most recent 1000 tweets. Okay, so looking at the same search words as we did before, but now having this location information, which we've called loc. So we've got the latitude in order here, the latitude, longitude, and the search radius, as well as the units like this. And then we've also specified our dates. So we're going to look at tweets from the 10th of July 2021 to the 12th of July 2021. So these can be changed. And once again, we will filter out any retweets and replies. Okay, so let's run this again to make sure it's all working. Okay, once again, this will take about 2 minutes to run, so I will pause and we'll return after 2 minutes. Okay, so we're back, and it's taken 1 minute and 34 seconds to collect these tweets, and it's collected 810 rows, so less than the 1,000 that we requested. And this is because of the area we've chosen. Most likely we've chosen this area here, centered on around Zambia, and a search radius of 1,000 kilometers. But because there aren't that many tweets, aren't that many people tweeting, this may be specifically about COVID, from that location, even though we're looking over 2 days, we've obtained just 810 tweets. So this is also something that participants will want to bear in mind when creating their research question. You know, they will have to think about how they can get enough data in order to be able to make some sort of legitimate or draw some legitimate insight to their research question. Okay, so just to go over those search parameters again, sorry, we've just put in these extra parameters of the geocode, which has the location that we specified above, and the since and until dates in order to specify the period over which we'd like to obtain tweets from. Okay, and so now after this geocode has been put in place, we will see that each and every tweet will have should have location information, and this should be according to the geocode. So should align with Zambia, Zimbabwe, and whatever was in this specified search radius. All right, so I think that is it, and we've just said that as an additional challenge, the participants can try out a few different queries and just play around with, seeing how many sort of responses they get, or if they look at different topics, topics unrelated to COVID, any other sort of topics that they may be interested in, and experiment with collecting from various regions, different regions around the world, different topics, just to see what kind of tweets they get and what quantity of tweets, what sort of various insight they can draw from just looking at the tweets I get from displaying the tweets in the data frame. Okay, so we also do tell them to not, a reminder here, to not exceed 1,000 tweets per query, as they will most likely be rate limited. If they are rate limited, there's nothing to do but just wait until that time has passed before they can run more queries. But if they'd like 1,000, more than 1,000 tweets, if they're collecting from a region that allows for that, they will simply run the query, and then just make sure they wait a minute after they've obtained their 1,000 before running the query exactly the same once again, but perhaps over different days, so as to not duplicate the same tweets. And just to specify again here, we've asked for the ID of the tweet, the date and the time, location, and the full text of the tweet. So the ID is useful sometimes when trying to keep track of tweets and making sure that you don't have duplication. And that's the reason for using the ID. Or there may be other reasons that one would want to have the tweet ID that the participants may run into, given their respective research questions. Okay, so we just also tell them that these are the things or skills they would have learned from this tutorial and should be able to do at this stage. If they get to the end of this tutorial and go through this and feel like actually they don't think they can, or they've fully understood any of these skills, they should then go back, go through it and ask for assistance, as they will most likely need all of these skills for the hackathon task. Okay, thank you very much for that. And that brings us to the end of tutorial 1. And I hope that this video served you well and provided some clarity on this first tutorial.